Go over here at the sideboard with me. Algebra 1. Can anybody tell me what SWBA stands for?
Students will be able to.
Awesome. Students will be able to. Thanks, Abby and Raquel. Okay? T is silent. The T is silent. Okay.
It's like in Spanish.
Yes. Solve equations for a specific variable. Section 2.7.
Yeah.
So sometimes some equations have more than one variable. You see this a lot with formulas, especially in formulas, whether that's in geometry or later on math, or in science quite a bit. You see formulas with multiple variables. So it can be helpful to isolate or get by itself one of the variables. Up to this point, we've only seen one variable each time, whether that variable is x, a, b, z, y, you name it, okay? Now we're going to see two or more. And we're going to be asked to solve for a specific variable. So on number 1, 15 equals 2n plus 6p, and we're supposed to solve this variable for n. So we have n and p, but we want to get n by itself. So the question becomes, well, how do we get n by itself? Now, a lot of us might look at this and be like, I don't know what to do. But we actually are going to follow the same steps as if this p wasn't there. What would we do if that p wasn't there and we were solving for n? We'd subtract 6, right? Now here, instead of subtracting 6, I'm actually going to subtract 6p now.
Wow.
So same idea, but instead of subtracting 6, I just subtract 6p. And I ask myself, what is 6p minus 6p? 0. So did I accomplish my goal of getting that away from my 2n? Yeah. Now I also have to subtract 6p from the other side because I have to keep things equal all the time. So just remember, whenever I do something to one side of the equation, I have to do it to the other.
But there's the p, so how do you...
That's a great question. There's no p. If it was 15 minus 6, we would say, oh, that's 9. But we can't. We can't combine 15 and negative 6p because they're not like terms. We can't call that 9p. That's not how that works. Now, what we do is we just write 15 minus 6p. We can't actually do it, so we're just going to write it. So we don't know what 15 minus 6p is because we don't know the value of p. But we can write 15 minus 6p. We just literally write what's there.
So you just move to the other side of the equation.
Yeah. Yeah, because we're just trying to get n by itself there, so we did move to the other side of the equation. Now, how would I get n by itself in any other circumstance? Divide by 2, because it's multiplying. So I'm going to do the same thing and divide by 2. Question. Well, what do I divide by 2? Is it the 15 or the negative 6? Trick question. You actually divide the entire thing. You actually have to divide everything on that side. You can't just pick and choose and say, I'm only going to divide this one thing. You have to divide everything because if we had been able to combine these, we'd have to combine them before dividing. So we'd be dividing the entire thing anyway.
But don't you have to... Would you have to subtract that to divide it though?
Great question. So Abby's saying, but Mr. Kossel, we won't be able to do this division, right? Is that kind of what you're saying?
Yeah.
Like, wouldn't we have to finish subtracting in order to actually divide it? And she's right, we would. But we can't finish the subtraction because we don't know p.
There's no solution.
So not quite. No solution is when we get down to only a variable with, no variables and a non-zero equation. But we do have variables. So what we're going to do is on the left-hand side, we don't know what 15 minus 6p divided by 2 is. But we can sure as heck write it. So we don't know what it is, but we'll just write it there.
That makes sense.
On the right-hand side, 2n divided by 2 is just n. So we ask ourselves, is n by itself?
So that's the answer?
That's literally the answer. It makes some of us really uncomfortable. Like, straight up, I'm not going to deny that. It makes some of us very uncomfortable to see that and be like, but it's not done yet. But actually it is. Because we are asked to get n by itself, and at the end of the day, n is by itself. Now, if this had been just a normal number, like 6, would this be done? No, because we could actually subtract and divide. But we can't actually subtract and divide, finish it off right now, because we don't know the value of p. If we were told later, hey, p equals 1, or p equals 2, or negative 5, or whatever, could we plug p in and then finish it? Yeah. So it's like one step away from being done, so to speak. But this is as far as we can get right now. We followed all the same steps we would have, though, if it had been no variable with it, if it had just been negative 6.
Yeah.
Or positive 6. Maybe. Let's look at number 2. K minus 2 over 5 is equal to 11j. K minus 2 over 5 is equal to 11j. And what variable are we solving for here? K. Yep, solving for K. So K is being subtracted and divided. Jack, what would you do first here? I agree with you. Let's multiply by 5. Or 5 over 1 if we prefer. And because I do it to one side, what else do I have to do? Do it to the other. Multiply by 5.
So 55.
So on the right side, we do get 55j. On the left-hand side, those 5's reduce. And so after with k minus 2, we have k minus 2 equals 55j. Bless you, and bless the rains on Africa, I forget. That was like a silent sneeze.
Have you heard Miss Phillips sneeze?
I don't think so.
She's like,
Oh, yeah?
it's like Samantha McKnight.
Yes.
All right, k minus 2 equals 55j. Is k by itself yet?
No.
So what do we have to do?
Add a 2.
Add 2. Now I'm going to add 2 to both sides. And negative 2 plus L is going to be 0. So we're left with k, which is what we want. Do we know what 55j plus 2 is? No, but we can write it. So we write 55j plus 2.
But how could you come?
Is that
That is going to be the answer, because k is by itself. Why can't we combine them and make it 57? They're not like terms, because j is a variable. So 55j has a variable with it, but 2 doesn't. So they're not like terms. If it was 2j, we could combine them. Eli. Great question. So you can do multiplication and division, even though they're not like terms, but you can't do addition and subtraction when they're not like terms. Why? Because we can say we have 5 groups of this and say, okay, well, you're just saying we have 5 sets of 11j. So in total, you'd have 55j.
You know how uncomfy this makes me? I don't like this.
It's a pretty it's a pretty typical reaction.
No.
Okay, that's a great question though about the
Come back.
That's a great question about the multiplication and division versus the addition subtraction. So we can combine, when we say combine like terms, we're talking about combining them. Okay? Ladies. Okay. We're saying adding and subtracting, combining. Multiplying and dividing, we don't consider that to be called like combining like terms. Okay? So that's why we're able to do 5 times 11j and get 55j, but we're not able to do the 55j plus 2, because to add and subtract, we need them to be like terms. So we just leave our answer like that, because k is by itself. And we can't actually finish the addition. Yes?
Okay, how is it that in the first problem that we could not divide by 2? That in this problem we could multiply by 2?
Great question. Why in the first problem could we not finish the division by 2, but in this problem we could finish the multiplication of 5? Well, the truth be told, we could go a little bit farther in this division. We'd have to split up our fraction. So if we wanted to go a little bit farther, we could, and say 15 over 2 minus 6p over 2 equals n. And say 15 over 2, we could keep it as 15 over 2 or call it 7.5, either one. 6p over 2 would turn into 3p. So you can make this your answer if you wanted. And I'm fine with either one. But if the denominator doesn't go evenly into both the numerators, then I'm actually okay with you leaving it like the blue up here where my pencil's at. But if the 2 were to go evenly into both 15 and 6, like maybe it said it was over 3, then I'd want you to reduce it because it's going to reduce more evenly. But I'm okay with you leaving your answer up here when it doesn't reduce evenly into both versus going down here. But if you want to do this, you're more than welcome to. So the answer is we can keep going with the division, but I'm not making us because I really don't think it's that much cleaner, personally.
It makes too much more.
Oh, okay. Well, hey, let's keep going.
I told Mr. McClain I don't like his class. Halfway today.
Okay. Number 3, 2w minus 7, or excuse me, 2w minus y instead of minus 7. 2w minus y equals 7w minus 2. What variable are we solving for here? W, okay? So we see w's on both sides of the equation, right? What have we done before when we see the variable on both sides of the equation?
You have to add like the
Yeah, you move one to the other side to get them together. Okay, because we want to get the w's together. So how would I move the 2w if I wanted to move that one? Subtract it. How would I move 7w? Subtract it. So which one would I rather do? Subtract by 2 or subtract by 7? Probably by... Okay, you could do either. I heard a couple more 2, so I'm going to subtract by 2. It's going to keep it positive, but if you want to subtract by 7, you totally could. So let's subtract by 2w on both sides, though, because that's one I heard more of. 2w minus 2w is 0. Don't forget, this isn't just y, it's what kind of y that's left. Negative y. We have to take those symbols with us. Equals 7w minus 2w is 5w minus 2. Now, w is not quite by itself. What do we have to do next? Get rid of the negative 2. Or you're saying y. Okay, we're trying to get w by itself. That'd be correct if we were getting y by itself. So how do we get rid of this negative 2? Add 2 to both sides.
But you can't add 2.
Yeah, but you can't add negative y and 2. They're not like terms. But you can write it. So we can write 2 minus y or negative y plus 2. I'm good with either order. So you can write 2 minus y because it's a positive 2 and negative y, or negative y plus 2. As long as the negatives and the positives stay with the thing they're supposed to. Equals 5w, because negative 2 plus 2 is 0. Then divide by 5, because that's what we would do normally. And we divide the entire thing by 5. Now, once again, we could split the fraction on the left-hand side. We could call it 2 over 5 minus y over 5. But I really don't think that cleans it up much. So you can, you don't have to. Or we can leave it like this. 2 minus y over 5 equals w. Is w by itself? Okay, we're done. Because right now, there's not really more math we can really do that's going to help us.
this next one seems fun.
Next one seems hard. Right? 3/4 a minus x equals k. 3/4 a minus x equals k. Why do you say it seems hard? Okay, it has a fraction. Okay, we see fractions. We're like, it's going to be hard. Okay, and it's 3 variables. Okay, well, let's not panic with fractions. Okay, let's not freak out and be like, we're lost. Okay, we can do this just fine. Okay, 3/4 a minus x equals k. And what's variable we're solving for? A. We're solving for a. So it's being multiplied by 3/4, subtracted by x. Which one would we undo first? We're going to take care of the x first. Because the fraction's only with part of it. The negative x is not part of the fraction. So we'll get rid of that first. So as we said, getting rid of the x first, we're correct. We're going to add x to both sides. Negative x plus x is 0. So we're left with 3/4 a is equal to k plus x or x plus k. You can add in either order. Now, 3/4 is multiplying with a. How do I undo that? Times by 4 over 3, right? Very good. Reciprocal. Very good. Reciprocal if you want. We would try to divide. That creates a double-decker fraction. So we multiply by 4/3 on both sides. Those 4s on the left-hand side are going to reduce. The 3s are going to reduce. So we're left with a. On the right-hand side, we could do one of two things. I'm fine with either. Because it's a messy fraction, I'm okay with leaving it as 4/3 k plus x. Or you could distribute it and say 4/3 k plus 4/3 x. Okay? If it's not a messy fraction, then I would want us always to distribute it. When it is a messy fraction, I can be okay with the top one. We ask ourselves the question, is a by itself?
Yes.
Yeah, we're done. Even though this looks anything but finished, because what we're used to is getting something equals a number. That's not what we have right now. So it kind of makes it a little uncomfortable. Questions on this so far? Eli? Yep, you could leave it like this one, yep. Yep, the step above. Only because it's a messy fraction. Okay? So I make some exceptions when it's messy fractions because even the step below it doesn't really clean it up much either. Okay? Great question. Continuing on. Flip the page. We're going to see an instance where this is actually helpful now. We're going to see an instance where it's a little more helpful. So we're given this equation, 6x minus 2y equals 4. And we're told to find the value of y, find what y equals, for these different values of x's. So we're saying when x is negative 1, what's y equal to? When x is 0, what's y equal to? When x is 2, what's y equal to? So what would we do with those x values? Plug it in one at a time, right? We plug in x once, solve for y. Plug in x again, solve for y. Plug in x again, solve for y. So how many different times are we going to have to solve for y? 3 times. So what we could do is we could plug them in right now, or we could solve for y first and then plug them into the new equation. This is where this might be helpful to solve for a variable, is when you're doing the same thing over and over and over again. If you were just doing it once, it'd probably be faster just to plug it in right now. But if you're doing it multiple times, like we are here, a lot of times it's faster, and it can be easier math, actually, simpler math, to solve for y first. So let's try solving for y first. How do I get this y by itself in this equation? I subtract the 6x. Let's see what mustarding's on after, let's forget. 6x minus itself is 0. We're left with negative 2y equals, we don't know what 4 minus 6x is. That's okay. We can still write it. They're not like terms. We cannot add or subtract them, aka combine them. Is y by itself yet? No, what do we need to do? Divide by what kind of 2? Negative 2 on both sides, the entire thing. Now here, on the right-hand side, does negative 2 go evenly into both 4 and negative 6? Yeah, it does. So this time, I would want us to actually do the division. Because it goes evenly into it, we can actually make it look cleaner. What's 4 divided by negative 2? And what's negative 6x divided by negative 2? Positive 3x. So that looks a lot cleaner than it did with the fraction, doesn't it? Y equals negative 2 plus 3x. That looks cleaner than it did before. So when we can actually take the denominator and it goes evenly into both everything on the numerator, that's when I'd want us to go through and simplify it like that. Okay? You can otherwise as well, like we talked about earlier, but you don't have to until we get here. Now I want you to. So now we have this equation, solve for y. This is going to help us when we plug in these different x values. Because now, when I plug in the x values, I can plug it into this equation, and it's going to be easier to find y than it would have before. And we'll see that here. So when x is negative 1, I'm going to take this equation, y equals negative 2 plus 3x, so when we just solved for y, and I'm going to plug in negative 1 for x. Because we're asked to figure it out with these different values of x, and that's my first one. Jace, put that down, please. Y equals negative 2 plus 3 times negative 1. So we're asked to find out what y is when x is negative 1, so we're going to do that now. So we're not solving for we're not solving for a variable anymore because it's already been done. So we're going to do our normal order of operations now. We did our backwards one when we're solving for a variable. We've already done that. So now we're going to be doing a normal order of operations. So what's 3 times negative 1? So y equals negative 2 plus negative 3 or minus 3, either way you want to see that. What is, and that's recall what? So y is negative 5. When x is negative 1, y is negative 5. Now, what do we need to do next? Plug x in as 0. So we're going to try another one. When x is 0. So we're going to take the same equation we just solved for y equals negative 2 plus 3x, and we're going to plug in 0 for x. Give a second to write that down. So what is 3 times 0? 0. So do I need to write negative 2 plus 0? No, I can just write y equals negative 2. And so y equals. We have to do it one more time when x equals 2. So we're going to have our same equation, y equals negative 2 plus 3x. And we're going to plug in 2 for x, excuse me. So what's 3 times 2? 6. So y equals negative 2 plus 6. What's negative 2 plus 6? So we answered our question, which was to find y given these different values of x. Now, like I said, what we could have done, if we wanted to, was plug each of these x values in to this original equation and solve it each time for y. Now, personally, and I would think many of you would agree with me. It's okay if you don't, but I think many of you would. I would rather plug x into this equation up here, which is the same one each time, than this equation to solve for y. Because all we have to do here is multiply, add, multiply, add, multiply, add. We're done. So we did more work at the beginning to make our work later easier. The other way would have been doing no work at the beginning, but the work is harder each time. So there's kind of the give and take to it. So once again, it makes it more worth it the more you do. You guys remember talking about that camping problem the other day of like, how many nights is it worth it to camp and get the membership for? You guys remember that? Ended up being like 9 nights, and if you camp less than that, don't even bother with the membership. You're going to pay more money. If you camp more than that, well, let's use a membership. Same idea here. When we are plugging in quite a few different things, yeah, it's worth it. Let's solve it ahead of time. When you're just plugging in like one thing, it's not worth it. Let's just plug it in and then solve. Okay? You always can do it. It's like you could always buy the membership or not buy the membership. But sometimes it's worth it and sometimes it's not. Does that make a little more sense maybe? Okay. Well, I don't want to wish you bad luck. Okay. Using formulas. So like we talked about, sometimes we'll need to use formulas. So when using formulas, sometimes we want to use what's called dimension analysis, or dimensional analysis, which is the process of carrying units through a computation. So it might be like converting meters to inches, okay, for example, okay? You do this a lot in chemistry, especially. This happens a lot in chemistry, in physics. So here's some problems that we're going to do. We're going to do 2 problems, but they are parts A and B each, so it's really kind of like 4, okay? You know that classic like math teachers, they're like, guys, we only have 3 problems, but they're like there's like A through F, okay? I don't normally do that to you guys, but here's one time I am doing it, but I'm upfront about it, so it makes it better, right? Okay. Number 1, a car's fuel economy, capital E, in miles per gallon, is given by the formula capital E equals M over G, where M is the number of miles driven and G is the number of gallons of fuel used. M is the number of miles driven, G is the number of gallons of fuel used. This is an actual formula. I use this all the time when I drive, okay, to figure out my mileage in my car. Because it's actually useful to know, so I can estimate later if I'm going on a trip, about how much do I need to budget for the gas on this trip, based on how far I'm driving. Or is something wrong with my car because my mileage has changed a lot between my last 2 fill-ups. So maybe something's wrong with my car, I know I need to take it in. So it can be a helpful thing. Anyway, so solve the formula for M. So we're asked to solve this formula for M. Capital E equals M over G. How would I solve this for M?
Multiply by G.
Multiply by G. It's being divided by G.
How do you do that?
We're just going to write it. Oh, it's a comma. So this is a formula where this is it. So it's more information falls. That's a fair question. Yeah, it's not an exponent or anything. Thanks for asking though, rather than just sitting there confused. Now, do we know what G times E is right now? No, but we can write G times E. Maybe if my pencil works. We can write G times E. And what's going to happen with those 2 G's on the right hand side? Reduce. I like it. So G times E equals M. Our number of gallons used times our miles per gallon will equal our number of miles driven. Okay, so we solve for M. Okay, well, here's why it's going to be useful. Letter B, if Claudia's car has an average fuel consumption of 30 miles per gallon and she used 9.5 gallons, how far did she drive?
Wouldn't it be easier to just take 30 times 9 and then add 15?
What?
Right?
I get what you're saying, yeah. Okay, so she has an average fuel consumption of 30 miles per gallon. Miles per gallon. Where do we see miles per gallon up before with our formula? E, that's our E. So 30 miles per gallon, that is our E. Probably good to note. 9.5 gallons. What letter would that be? G for gallons. How far did she drive? What's that talking about? M. How far? Miles. So we have our E, our G, and our M. So what are we solving for? M. Hey, do we have an equation that's already solved for M? So could we plug these things into the equation that's already solved for M to figure out how far she drove, which is M? How many times can I say M over and over and over again? Okay.
I don't know.
So we're trying to find how far she drove. So that's the number of miles. We know the economy. So we know the fuel consumption of the economy. And we know how many gallons she used. Well, we already solved for M. Probably done on purpose that we did that. So now we can just plug things in. With an equation, with a formula, you always just take what you know and you plug it in and you solve for what you don't. So we know E and G, so we're going to take G and plug it in at 9.5. We know E, so we're going to plug it in at 30. And we're going to solve for what we don't know, which is M. So a general rule of formulas is you always plug in what you know and you solve for what you don't. So we do 9.5 times 30, and as Abby Simmons must have said, it is 285 miles. Okay, what?
I didn't do it like that.
Yeah, but that's what you had.
Yeah, that's what happened.
Well, you did 30 times 9.5, right?
No, I did 30 times 9 and then added 15.
Yeah, because you did 30 times 9 plus 30 times 1/2, which is 15. Yeah. Yeah, 30 miles per gallon is pretty good mileage. And she'd get 285 miles on less than 10 gallons. Pretty good. She might. Honestly. Sarah, what's up?
What does that word say?
Dimensional. Great question. That's really ugly, isn't it? All right. Speaking of the dimensional, let's talk about that. How would it be used here? Okay. Well, here's how it would be used. We had 9.5 gallons. If I can write it, 9.5 gallons. And gallons was being multiplied with our 30 miles per gallon. What does per mean? Per means what operation? What did you say? Dividing. So we have miles per gallon. So we are taking 9.5 gallons, multiplying it with our 30 miles per gallon. So if we put gallons over 1, pretend like these are numbers for a second. Pretend like these units are numbers for a second. Our 9.5 gallons with nothing over it, with nothing under it, just our 1. And 30 miles per gallon, miles divided by gallon. Abby, come up here, please. Thank you. Okay. What would happen with these gallons if we were doing multiplication? They would reduce. And what would we be left with?
1 mile.
Just miles. And so that's what we're left with our unit. So that's how we end up getting miles as our unit that's left, is because there's actually math involved with it. All right, let's continue on to the last two-part problem. The formula for volume of a cylinder is V equals pi r squared h, where r is the radius of the cylinder, h is the height, and pi is just pi, which is 3.14159, keeps going forever. Solve the formula for h. We have V equals pi r squared h. Solve for h. Well, what's happening with h? That's the question I always ask you guys. What's happening with our variable? It's being what? Multiplied. How do we undo multiplication? Divide. So we know we're going to divide. Question now, divide by what?
Pi r squared.
pi r squared, because that's what's multiplying with h. You divide by whatever is multiplying with it. In this case, it's pi r squared. Do we know what v divided by pi r squared is? Nope, but we can write it. And then pi divided by pi on the right side is 1. R squared divided by r squared is 1, so that's with h. So v equals pi r squared, or v over pi r squared is equal to h. And it's by itself. It's really weird. It's very, it seems so different and so counter, so opposite to what we've been doing, because we've been getting like a definitive answer like h is 1, h is 5, h is 9 over 2. But now we have like h is v over pi r squared, and we're like, what? Why are there so many variables? It's because we're doing formulas though. And we didn't get h by itself. So we're still doing all the same math we were before. It just looks a little different now. Okay. What is the height of a cylindrical swimming pool that has a radius of 12 feet and a volume of 1,810 cubic feet? Okay. We're asking, what is the height? Height is which letter? Cylindrical swimming pool that has a radius of 12 feet. So what's that? R. Volume of 1,810 cubic feet. Okay, that's V. Okay, so we are trying to find H, and we know R and V. Same thing with our formulas. We plug in what we know, solve for what we don't. Do we already have an equation that's solved for H? Yeah, so let's use this one. So let's use this equation, V over pi r squared equals h. And let's plug in what we know to that. So v is 1,810, pi is pi, and r is 12. So 1,810 over pi times 12 squared is equal to h. What is 12 squared? Anyone know? 144. I think you did 2 times 12. 144 pi, or pi times 144. We just typically write the normal number before pi. And then you would simplify 1,810 divided by 144. I'm going to go and tell you, though, this is approximately, I'm going to use some calculator math here, that h is approximately, those little squiggles mean it was rounded, but it's approximately 4 feet. If you were to divide that in a calculator, take 800 divided by 144 pi in a calculator, you get about 4 feet. Those are squiggly lines because it's not actually exactly 4 feet. It's just close to it.
Wait, so you don't do anything with the pi?
We actually use pi as like 3.14159 in the calculator. We won't have to do anything with pi on a test. But we could, if you wanted to just leave pi as pi, you could just reduce the fraction and do 1810 and 144 and say, okay, well, what goes into both, and go through that whole thing. Does that make sense? If I wanted to, I could say 1810 and 144. What goes into both? Well, 2 goes into both, or 4 goes in. 4 doesn't go into both, but 2 goes into both. And say, okay, well, it's 905 over 72. And I believe those numbers don't reduce anymore. So then you'd be left with 905 over 72 pi, and you can call that your answer. Or we can type it into our calculator, and we get about 4 feet. Yeah, they'll give you like 4 point something. If you type in 1,810 divided by 144 pi. Yeah, it goes on forever. So you can type in, there's a pi button on most calculators, or you could type in 3.14 and get an approximation. So there's a couple different ways you could do that. Now, I am a big fat meanie head, as you guys know. Okay.
Homework.
So we do get some homework.
Every single time you say that, I know for a fact it's homework. I am a big fat meanie head.
Yeah, I just want you guys to know. Okay? But I have some don't do's. So those are our 4 don't do's on the lower left-hand corner in the orange. 11, 12, 14, and 15. So you guys can cross them out if you would like.